In this video, I am going to solve the problem 42nd from chapter 16, Waves Part 1. The equation of a transverse wave traveling along a very long string is y equal to 3 sine 0.020 pi of x minus 4 pi t, where x and y are expressed in centimeters and t is in seconds. So you have the wave, which is a transverse wave, and its respective wave equation is given. So better I can write the equation one more time. So y, which is equal to 3 sine 0.020 pi multiplied by x minus 4 pi multiplied by t. I have to close the bracket. Clear? And here the x and y are expressed in terms of centimeters. So in this question, you have many subdivisions. Let's we answer one by one. So in the first part, you have to find what is the amplitude. As we already know what is the amplitude in the wave equation, the first one is the amplitude, and this part is the angular wave number k, and this part is angular frequency omega. So here the value of the amplitude, there is no unit, but they already mentioned here x and y are expressed in terms of centimeter, so you have to give the unit for the amplitude. So first question, amplitude in this equation is 3 centimeter. If you want to give the answer in terms of meter, 3 multiplied by 10 power minus 2 meter. This is the answer for the first question. So we have to pick the data, pick the value from the equation. Clear? Okay. In the second question, we are going to find what is its wavelength. So how to find the wavelength? It's very easy. So we have to identify the wavelength from the equation of angular wave number, because here the angular wave number is equal to 0.020 pi, which is equal to the equation for the angular wave number is 2 pi over lambda. Clear? So I am going to find the value of the lambda from this value. Clear? So here I just wrote the formula for the angular wave number. So I took the value of the angular wave number from the wave equation, which is already given in the question. So here I'm going to rearrange this equation in terms of lambda, because we are going to find the value of the wavelength. Therefore, the wavelength lambda is equal to 2 pi over 0.020 pi. So we can cancel pi with pi. So here you have 2 over 0.02. If you divide 2 with 0.02, you will get the answer of lambda as 100 centimeter, right? Clear? Okay. What is the third question? In the third question, we are going to find what is its frequency. So I am going to find the value of the linear frequency by using the angular frequency of 4 pi. So here in the equation, angular frequency is 4 pi. So I'm going to use that value for finding the linear frequency. In the third part, omega, which is equal to 4 pi, and this omega, which is exactly equal to 2 pi f, right? So I'm going to equate these two. So this value 4 pi is already given in the question, and the formula for the angular frequency is 2 pi f. So we can easily equate. Am I right? So in this equation, I'm going to equate in terms of the linear frequency f, which is equal to 4 pi over 2 pi. So you can cancel. By that, you will get the linear frequency as 2 hertz, right? Is the answer for the third question. Now we have to go for the fourth question. What is given in the fourth question? We are going to find the speed. So how to find the speed? It's very easy. In the part B as well as C, we've already found the value of the lambda as well as the linear frequency. By using this, I'm going to find the speed. So therefore, the speed, which is equal to frequency multiplied by lambda. So here the frequency is 2 and the wavelength lambda is, what is the value of lambda? 100, right? So 100. So here the answer is 200 centimeter per second, because everything is mentioned in terms of centimeter. So we have to give the answer in terms of centimeter per second, right? So this is the answer for this. If you want to go for another method, we already know the speed, which is equal to angular frequency over angular wave number, and angular frequency here they mention as 4 pi over, and the angular wave number is 0.02 pi, right? So we can cancel this. If you divide 4 with 0.02, you will get the same answer. Clear? So you can go for any one of the method. The answer will be the same. So 200 centimeter per second. Clear? Okay. So now we have to go for the fifth question, which is E part. Am I right? Determine the direction of the propagation of the wave. So how to find the propagation of the wave? We can identify which direction the wave is moving. So we already solved one question in the previous video. Am I right? So if you want to find the direction of the propagation of the wave, you have to see the sign here. In the wave equation, if you got the sign here as negative, that wave is moving in the positive direction of the x. If you got the positive value here, that wave is moving to the negative direction of the x. So here in this question, they gave the wave equation. So especially in the phase, am I right? This is the phase, am I right? So here they mention negative. That means this wave is moving in the positive direction of the x. So which direction the wave is propagating? The wave is propagating in the positive direction of x. So this is the answer. Clear? Okay, now we have to go for the sixth question, F part. Am I right? Calculate the maximum transverse speed of a particle in the string. So how to find? Actually, we already studied chapter number 15. Am I right? Oscillation. So in that we studied the formula for the maximum transverse wave. So better I can write the formula directly. Okay. So our sixth question, which is F part, V max, which is the maximum speed, which is given by the relation omega multiplied by the amplitude, right? Actually, we got negative value. We are just going to only the magnitude of the V max. So you have to differentiate by that. You will get the negative value. Actually, this is negative of omega ym, but we just go for only the magnitude value. So here, as we already know, omega, which is equal to 2 pi f. So I am going to substitute this omega here. So by that, this equation will become 2 pi f multiplied by ym. Ym here is our amplitude, right? So 2 multiplied by pi multiplied by frequency. What value we got in the frequency? I think 2 hertz, right? Yeah, 2. So we got the frequency, linear frequency as 2 multiplied by the amplitude. What is the amplitude? So we have to go back to the question, especially the equation. So here the amplitude is 3 centimeter, right? So 3 centimeter. So I'm going to multiply 2 multiplied by pi multiplied by 2 multiplied by 3. I got the answer as 37.699. So I can write 37.70 centimeter per second. Clear? So this is the answer, V max, maximum speed of the transverse wave. Clear? Okay. Now we have to go to the seventh question. I think this is the last question. Okay. What is the transverse displacement at x equal to 3.5 centimeter when t equal to 0.26 seconds. So we are going to find the displacement of the wave, right? Transverse displacement. For this, we have the displacement x value as well as with respect to the time. Its x value is 3.5 and its time is 0.26. So I have to take the equation. So better, what is the equation here? 3 sine 0.020 pi x minus 4 pi t. So I have to write this equation for getting the answer for the 7th question, which is g. Am I right? The part is g. So better I can write the equation y of x comma t is equal to ym sine of kx minus omega t. This is the general equation, but the equation they gave in the question is y equal to 3 sine 0.02 pi multiplied by x minus the omega value is minus 4 pi, 4 pi multiplied by t. And here they already gave the value of x. What is the value of the x? Just before we read, am I right? The value of the x is 3.5 centimeter when time t is equal to 0.26 second, right? So I have to apply. So how I can write this equation? I'm going to apply this equation, this value in this equation. Therefore, y of x comma t. So actually here we have x comma t, right? 3.5 centimeter comma 0.26 second, which is equal to 3 multiplied by sine 0.02 pi, and what is the value of x? Multiply with 3.5 minus 4 pi, the value of t. What is the value of the t? Which is 0.26. Now if you want to find the displacement, the transverse displacement, you have to multiply everything in the right hand side. So let's multiply. So 3 multiplied by sine 0.02 pi 3.5 minus 4 pi 0.26. I got the answer as minus 0.28 centimeter. So this is the transverse displacement. If x is equal to 3.5 centimeter when time t is equal to 0.26 seconds. So this is the answer for the last question. Clear? That's it.